Okay, strap on your boots and get your keyboards and your paper and pencil if necessary. We're going to have the review for 20% of the total course. If you followed instructions, which I assume you did, you went out and got yourself used chemistry textbook, which has lots and lots of material. You might even go on to Sham's Outline, which is available. I think they're 10, 15, 20 bucks. And Sham's Outline of General Chemistry provides you a lot of problems and all the different concepts that I've covered. Now, I majorly began the course with water, HOH, or H2O more commonly. Water is hydrogens and oxygen, with the hydrogens in a polar position, with providing the molecule with a negative and positive side. The next water molecule will adhere to the first molecule, giving it a adherence, which produces things like buoyance, surface tension, capillarity, a variety of attractive characteristics of water molecules, one for the other, and resistance to being interrupted with that adherency. Next on the agenda, we have the periodic table. Now, the periodic table starts out with two elements above it. Hydrogen, which I guess I probably write a little differently. Hydrogen, which is 1s1, and if you're drawing it, it's a layer like this. And then we'll go with helium as the first of the in column 8, and it's a 1s2. And if you draw it, it shows both electrons. Now, when we go to the next one, we have 1s2, 2s2 full, but the second shell has more than one suborbital. It has the p also. So the second column has 2 electrons available for interaction. First column has 1s filled plus 2s with 1 electron, or 2s1. So the first column can provide 1 electron for interaction. The second column can provide 2, etc., etc., ad nauseum. Out here on the other side of the periodic table, you've got 6, column 6, has 6 electrons available, striving for that magic 8. Column 7 has 7 electrons available, again, striving for the magic 8. Column 8 has 8 electrons, or in the case of helium, 2 electrons. So these are noble gases. Actually, they're inert elements, which was later found that all of them are gases. So column 8 is all gases, all non-reactive in normal chemical reactions. With 6, you would take a 6 element, what the heck, let's use calcium. 2 plus, because it needs 2 electrons to satisfy its scenario. Add it to something in the second column, or this is the second column, my bad. Out here in the 7th column, it would be chlorine. which is a -1 charge. Now you can see by up front, if calcium needs 2 electrons and chlorine can provide that electron, there has to be 2 of them. So the formula would be CaCl2. 2 of these needed to counteract the 2 plus. All right, that's kind of a pseudo journeyman introduction to the periodic table. All right, let's talk about some balanced equations. I like my balanced equations. Now, we had one already, but one that's quite often used is sodium hydroxide which is a nasty substance, incidentally. It's caustic lye, and you add a very nasty acid. In other words, both of them maximum concentration, equivalent molarity. When you put them together, you got a caustic lye, which will burn your hands if you put it on it. You got 12 molar hydrochloric acid, which is as concentrated as it gets, and you put them together, and you come up with something you wouldn't expect. Hot salt water. Why is it hot? Because the reaction of the acid and the base produces heat. A salt, in this case table salt, sodium chloride, and water. Or some people like to say produces a salt and hot water. Either one is acceptable. Again, a simple balanced equation. All right, sig figs is next on the agenda. And mostly I want you to try to keep in your mind that when you're doing laboratory measurements or chemistry problems, that the final answer, number of significant figures, is always limited by the least accurate component of your problem. If you do that, sig figs, it's just not that big a deal, but you can't forget it. When you go to summarize, put your answer down, you look back at the components of the problem and say, oh, I only had 2 sig figs, so my answer is limited to 2 significant figures. Now, does that change the answer? Probably not, but you'll have to account for it with exponents. Exponential functions are quite handy for that. All right, let's see what else we got here. Avogadro's number, which is that made-up number of 6.022 times 10 to the 23rd. We'll say atoms per atomic weight. Or atomic mass of the substance. For instance, 23 grams of sodium is going to be 6.02 times 2 times 10 to the 23rd atoms of sodium. Plus 35.5 grams of chlorine is going to be 6.022 times 10 to the 23rd atoms of chlorine. You add them up, you get 58.5 grams of sodium chloride. That's it. Now, the thing you got to overcome in your mind is, well, wait a minute. We got 6.022 times 10 to the 23rd, and we added another 6.022 times 10 to the 23rd. Shouldn't we have 12.044 times 10 to the 23rd? No, because once you took the sodium and the chlorine and put them together separately, you now have a molecule of sodium chloride that weighs 58.5 grams and contains 6.022 times 10 to the 23rd. And instead of atoms, we have molecules. Now, some of the instructors will go berserk because I use atomic weight. Don't let that get under your skin. They like to use atomic mass. All right, it's potatoes and potatoes kind of thing. So don't let it bother you. Again, the sodium plus chlorine producing 58.5 grams per mole. Again, this is atomic mass, which is grams per mole. And now we get 58.5 grams per mole. And in itself is equal to 6.022 times 10 to the 23rd molecules. And now we're past the atomic mass, molecules per atomic mass. It's now molecular mass. Or molecular weight, if you want to call it that. Okay, that's kind of a crowded view, but it's pretty accurate. All right, what else? It covers the mole concept, equations, balancing. You just get to spend the time going over them. Let's talk about acids. The acids that you will deal with pretty much are hydrochloric, sulfuric, and glacial acetic. Now, glacial acetic acid in 5% concentration you're really familiar with, because that's pickling vinegar. Vinegar is glacial acetic acid diluted. Concentration, it's like 17.5 moles per liter, which is quite strong. Not something you want to mess with. Hydrochloric acid, we talked about it before. Its molarity as it comes out of the digestive glands in your digestive tract is 6 molar. Now that's bad enough to blister the back of your hand if you were to put it on the back of your hand. And because of the mucus layer in the digestive tract, which is basically acidically resistant, you don't have any problems. Now, if you get a breakdown of that mucus layer, then you get a destruction and localized destruction of the lining of the digestive tract, producing what's called an ulceration. And that's one of the ways that you get an ulcer. Not a very pleasant experience, I'm told. All right. Caustic lye, sodium hydroxide, used for a lot of things. Drying agent, quite poisonous, and quite corrosive. Okay, next will be Stoichiometry.